Hello everyone, it's Mr. Hine here. Here's a video on how to do the first assignment. Before we start, let's just do some meditation breathing if you want. If not, what's great is you can just skip ahead. But we use this time to just get our brains to be in the moment because math's already hard. And if we aren't truly focused on it, it gets even harder if we're thinking about, boys and girls we like, or, what am I going to have for food later. Our brains aren't there ready to learn. So here we go. So sit upright in your chair if you want to join me. If not, skip ahead in the video. And if you feel comfortable, close your eyes. And again, the two main points is one, be aware of your thoughts, and two, just focus on your breath. So here we go. Be aware of whatever you're thinking about. Now just listen to your breath. Breathe in and out. Just like that again, in and out. And now if you adjust your nose in and out. How do you feel? Hope you feel a little bit better and you're like, what was I even thinking about before this? And if you don't remember what you think about before, it means you're getting better at it. And it takes a lot of time. I've done this for years, not just 2 days. So here we go. First one, if you want to follow along, if you want to copy this down for notes, you can. It's up to you if you just want to use this to help you do the work. But definitely feel free if you need to rewatch this several times. I know that when I was learning math, I would pause, rewind until I got it. And here's my best analogy. It's easy to watch someone do something. It's different when you do it yourself. And I highly recommend when you do these, see if you can do it yourself, not just watching me do it. And that's why you do the problems, not just saying, oh, I got it from the video. And my example is a year ago when I had a leak in my house, I could watch a 4-minute video on how to fix a leak. And it was easy. I was like, I got it. And then you know how long it took me to fix the leak? 9 hours, right? So easy to watch something, different to do it yourself. And once you do it yourself, you learn so much more about it. So here we go. So this is talking about tile patterns and simplifying expressions. I'm going to be going through it, but since it is a video, feel free to pause, move ahead if you need to, and so forth, so you get it. So the first one here is I have a tile pattern, and it looks like this. And tile patterns are really meant to help us just see patterns and learn how to generalize them. All right. So with tile patterns, there's two things you're looking for. The first thing you're looking for is patterns. Look for a pattern. We'll talk about that. And the second thing is how do you generalize it? And we'll talk about what that means too, because generalizing is when the real math gets into this and can apply to much bigger problems. So I look at this poem, I see these pictures, and I'm trying to find a way to see how it looks. And there's so many ways to do it. And note that the way I'm showing you right now might not be the way that you even see this example. You might see it totally different, and that's okay. So I see this one, I'm going to look at it as columns. So I see that here on the left, and I'm going to use highlighter here, I see 3. And then here on the left, I see 4. Where it added 1 right here. Like it looks like it went from 3 to 4 and it added this one. That was added. And then it went over here to 5 where it added 1 again. So it's adding 1 on the left column. And on the right column, it has 2, and then it looks like it adds these 2. So it's going from these 2, and then I think there's now 4. And then the 4, now it becomes 1, 2, 3, 4, 5, 6, where added these 2, 6. So sometimes when it helps doing these problems, I like to make a table here, and we'll call it figure number and number of tiles. Let's make a table, help us see this. And there is always a figure 0. We're going to skip that spot, but we're going to figure 1, 2, 3, we're going to go to 4. And figure 1, how many tiles did it have? 1, 2, 3, 4, 5. It had 5 total tiles. Figure 2 had 4, 5, 6, 7, 8 tiles. Figure 3 had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 tiles. So how much is it growing? Well, one way you can do it is you can say, on the table, it's going up by 3. You'd say it's growing 3 tiles. Each figure number, right? because technically it's going up 6 every 2, and we want to be clear with our words. So it's going 3 tiles each figure number. And that's your answer. That's how you do tile patterns. But there's a little bit more to this, and there's a lot we can get away from these. Do we know how many would be in figure 4? Well, because we see a pattern where it's adding 3, because this table's so nice, we know that if we just add 3 again, how many is going to be in figure 4? Well, there's going to be 14. And that's how you can get figure 4. And figure 0, since you see the pattern table, we can get this one. Well, if we're adding 3 to the right, what would we do going backwards? Opposite of addition is subtraction. So we could minus 3, and 5 minus 3 is 2. So then we even know that figure 0 has 2 tiles. Now to help us see us in the picture too, let's look at this pattern. Well, on the left side, it's going from 5, 4, 3. So it's subtracting 1. So that means the next one, if I went to figure 0, would just have 2. 5, 4, 3, 2. And on this side, it's going 6, 4, 2, and then there's nothing. So it's actually going down 2s. Minus 2, and then if you minus 2 again, there'd be nothing. So there's the 2 tiles. And figure 4, if we wanted to draw it, what on the left side, if I highlight this to help you see the left versus the right, it's 2, 3, 4, 5. So then there would be 6. And I'm actually, instead of actually getting 6 tiles, I'm just going to draw a rectangle, just put that there's 6 in it total. And the right side, it went 0, 2, 4, 6. And the next one is going to be bigger, and I'm supposed that there'd be 8, which notice 6 plus 8 equals 14. So we know we did it right. And that's tile patterns for you. Now, this is a little bit harder. This is a challenge for those of you who are capable of honors, which should be all of you. What would be figure 100? We skipped a lot in this table, and I said 100. How many tiles would be in 100? Yeah, you could draw figure 5, 6, 7, 8, and keep going to 100, but that's a lot of drawing. Power math, if you recognize a pattern, you can just apply it. And there are definitely different ways here. If I wanted to draw a picture of figure 100, and keep in mind, this again is a challenge. You don't have to do this. I don't think a problem asks you this, but this is honors level thinking. Now, when we draw a picture, I was drawing these pictures in a certain way and highlighting the numbers in a certain way. We did patterns, but remember how I said the word generalized way back in the beginning? What's that mean? Generalized means how does it relate to the figure number? So if we focus on just the left side here, how does 2 relate to 0? In the same way, how does 3 relate to 1? In the same way, how did we get 4 from 2? How do we get 5 from 3? How do we get 6 from 4? Maybe you see it already. And what it is it's really just adding 2 to the figure number. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2 is 5. 4 plus 2 is 6. So if it's 100, what's this going to be? Well, if we just add 2, it's going to be 102. And on the right side, we do a similar thing. How did we get 2 from 1? In the same way, how do we get 4 from 2? How do we get 6 from 3? How do we get 8 from 4? And if you see it, it's timesing by 2. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. So what's going to be if it's 100? Well, 100 times 2 is 200. So figure 100, if we add that up, is 302 tiles. Or some of you who might think it even differently, how much is it adding every time? It's adding 3. Well, how many times is it going to add 3 if it goes from figure 0 to 100? Well, it's going to add 3 100 times, which is 300. But then we didn't start at 0. What did we start at? 2. So if you add that 2 back in, you're at 302. Just a little bit challenge for some of you. Now, the second one here is simplifying some algebra, and I wanted to talk about this a little bit. A here says, what's negative 50 plus negative 5? So if you're adding negative and you're adding more negative, that means you're going to go more negative. You're going to owe more money. If you owe $50 and now you have to owe $5 more, well, then you're going to owe more. So we actually, this negative plus a negative actually goes more negative, which makes it negative 50 5. Now this one, this parentheses is separating the word -1. So this is 6 minus -1. Well, what's a negative? What do two negatives make? A negative times a negative is a positive. So this actually, because really what this is saying is there's an invisible 1 right here. Invisible. And then you have -1 times -1. And a negative times a negative is a positive. So it becomes 6 plus 1. And 6 plus 1 is 7. And if you want to know more about that, come to office hours and I can explain that. This is a little bit fast. And then the last one, again, it's multiplication. When things are touching, that's multiplication. So some notes in case no one has ever taught you this. If they're touching, that's multiplication. I'll write it in words. And then remember that with multiplication, a negative times a negative equals a positive. And a positive times a positive is a positive. But if there's any combination, if there's a mixture of them, like a negative times a positive or a positive times a negative, that's going to equal a negative. Okay. So these are touching, and we have a positive times a negative. And a positive times a negative is not the same as going to be a negative. So that takes care of the sign. And then what's 10 times 3? That is 30. And feel free to use a calculator if you want. You do by no means have to do this in your head, and that's okay. It would have been okay in a class either. All right, so there's the second problem. And the third one here says, find the value of y if x equals 3. Now what that means is these letters represent numbers. We just don't know what these numbers are yet. And it's actually saying, find what number y is. Well, okay, I'll try. But it says, here's a hint. X is the number 3. So what you do is you take what x is and you plug it into x. And very important, I'm going to start this, always plug in with parentheses. You know this trick, your math will get more organized. The more organized you are, the easier it is to do more complex problems. So I'm going to rewrite this. You have y equals 10 minus 4, but instead of x, I'm going to use parentheses and plug in 3. Now notice that these are touching. So you have y equals 10, and then minus, what's 4 times 3? 12. And 10 minus 12, you had a positive 10, you're taking away 12, you're going to go negative. So you get -2. So y is the number -2 there. And on b over here, same thing. We're going to plug 3 in. So rewrite it and use parentheses. Now what does squared mean? That means times itself. So 3 squared, or 3 to the second power, means 3 times 3. That's what it means. And then we're still adding 3. But what's 3 times 3? That's 9 plus 3, and that equals 12. Notice, by the way, how I work down, and I am going a little bit slower in these first videos. Work down, rewrite it step by step, doing one thing at a time. It feels slow, but go slow to go fast. The better your habits are, the easier, harder math will be, I promise you. That's coming from someone who has done many years of it. Hope this helps. Good luck on your first assignment. Try it all, show all your work, and come to office hours if you have any questions. All right, bye-bye now.